Well, hello and welcome to another DevNation Tech Talk. We're going live right now to broadcast you some Kubeflow. If you're interested in AI/ML workloads and how to deal with Kubeflow and TensorFlow and all those magical things in a Kubernetes and OpenShift world, we're going to talk about Open Data Hub today with Juana. Juana. I got to get it right. Juana Nakfour. Yeah. So Juana's going to educate us. She's going to be awesome, and it's going to be a lot of fun. And so we wanted you guys to basically get your questions together, throw them into the chat. I'll relay them. I'll relay them at the right appropriate time, but also feel free to just kind of take in this information. I'll be posting links in the chat as well. You already see I added a link to a GitHub repo you should check out, as well as Juana's Twitter handle that you'll want to check that out also. But at this point, we're going to dive right into this. So over to you, Juana.
Hey, how are you, everybody? Thank you, Burr. I know Burr brings a lot of excitement, and I'm going to try to follow his ways of presenting. So I'm going to share my screen right now. And today's presentation is going to be about Open Data Hub. My name, please get it correctly, Juana Nakfour. I'm part of the CTO AI Center of Excellence at Red Hat and one of the leads on the Open Data Hub project. For this presentation, I'll walk you through a lot of details about Open Data Hub, what it is, how it started, and how to contribute and join us in this project. And then we'll have a little introduction on Kubeflow, and then we have an exciting demo at the end on a couple of features that Kubeflow provides. So what is Open Data Hub and how did it start? As a project, Open Data Hub started internally within Red Hat. We had a lot of requests from data scientists to provide kind of a platform that gives them a place to store their data, and that's where the word Data Hub actually comes from. So it's evolved, and we started figuring out that a lot of the issues, or let's say challenges and things that we're facing inside, a lot of the teams, data science teams, AI/ML teams outside of Red Hat also face the same things. We tried to adapt this project so that we can tailor to these data scientists that are different users than what we're normally used to, which are DevOps users. They're more UI driven. Their challenges are different than DevOps challenges. One of the biggest challenges is how you share and collaborate. You work on a model. How do I share this model, right? How do I bring this model to production? How do I serve this model? And once it's in production, how do I actually monitor this model and keep updating it and make sure that it's predicting the right things that it should be predicting? And then after we decided to take this internal Open Data Hub or Data Hub project and platform and turn it into an open source project so we can involve the community and get more intelligence to it and bring it to the OpenShift users. So to set the stage, what is Open Data Hub? Open Data Hub is a community project. It is an operator today that you can download and install. If you have OpenShift and you go to the catalog and you go to the operator hub, I'll show you now in the demo at the end, and you search for Open Data Hub, you will see it there. So what does it do, right? You install it, what does it bring? It brings an end-to-end AI/ML platform. And what do we mean by an end-to-end AI/ML platform? If you look at the picture below, we try to include tools for all these different functionalities that happen for the AI/ML workflow, right? From the beginning of a data engineer actually bringing the data, transforming the data, ETLing the data, prepping it, making it accessible for the next person or the next developer, which is a data scientist, that gets this data, analyze this data, they try to see what models they can build, they build the model, they validate it, they train it, they optimize it. And once the model is ready, then it's the DevOps side maybe and the data scientists working together to figure out how they serve that model. And then once you serve that model, really that's not the end of it, because you have to keep going through this cycle, and maybe the cycle is not really clearly shown here, but the cycle is, optimizing this model. And when the process of optimizing the model is not just looking at the model, but also looking at the data coming in. Is the data coming in drifting? Is it the same data that you used to train the model? Is the model predicting accuracy still the same, or is it changing? How do I keep this process or this loop going on? So for all information on Open Data Hub, your starting point would be to go to opendatahub.io. It is our website. It is the entry point to all of the information with regards to Open Data Hub project. So with relation to all the downstream and upstream that we have within Open Data Hub. So Open Data Hub, like I said, is a meta project, meaning it's made up of all these different open source projects Some like Seldon, Argo, Jupyter, Kubeflow is the biggest one, Kafka, Prometheus, Grafana, Spark. All these contribute, go downstream to Open Data Hub. Open Data Hub packages them together in an operator and provides them an operator hub catalog on the OpenShift platform. So just to point out here that most of the stuff that we do in Open Data Hub that kind of adapt these tools to work better in OpenShift, we actually also contribute back to all these different communities. All the bugs or features that we make, we try to contribute upstream to these communities. So a little bit here about where Open Data Hub today is with regards to releases. So we started late last year, actually for a year and a half or so. We had the operator written in Ansible, and then the last release was Open Data Hub 0.5, and we have a lot of packages in it, which I will explain here in a little bit. But we did this big shift in the operator world to align better with Kubeflow. We actually converted the Ansible operator to Kubeflow KFCTL operator. And if you're not familiar with that, that's okay. So what it is, it's basically, there's a tool called KFCTL. I call it KFCTL, KF Cuddle, some people say. What it does is that it reads the manifests that are YAML files that are customized using customize, and then it runs the operator. It's based on Go. So today, when you try to download and install Open Data Hub, you'll see two channels. The first channel is the Kubeflow channel, which is the 0.6, and it has Kubeflow in it. And then the original one, which is 0.5, it's the legacy one, which is the Ansible operator. And we're keeping them like this for a little bit, just so we're a little bit more confident with the Kubeflow operator way. So the latest release of Open Data Hub was 0.6.1, which was released end of May, beginning of June, and that includes Kubeflow 0.7. So in the effort of getting Kubeflow, I will explain here in a little bit too, also in an introduction, but we basically adapted Kubeflow to work better in OpenShift, and then we integrated it in that operator. And then we tried to migrate all these different components that we had, such as Argo and Seldon, and we migrated to the KFCTL way of doing it, and we included it. So we did the component migration. Now down the line, end of June, we're going to have the 0.7 release of Open Data Hub. That's going to include Kubeflow 1.0. And then we have some components from Kubeflow that are not ready. We're not ready. We're going to get them, try to see to get them to work over OpenShift, such as KFServing. We're going to include CI and testing for Open Data Hub, and then mixing of Open Data Hub with Kubeflow components. So today, if you want to install Kubeflow or Open Data Hub in 0.6.1, they are isolated. They have to be installed separately. You can't mix and match between the components, but we're working on getting that one done. And then we're also working on trying to get a mini OpenShift container storage to be as part of the deployment of your Open Data Hub. That way you have storage also as part of your Open Data Hub. And then data catalog is also one of the components that we haven't migrated yet that was part of the Ansible operator Open Data Hub. We're going to work on migrating it. And at the end of August, this is a little bit more the 0.8, and it's a loose roadmap here. Might change, we might add or move some of the stuff. We want to have every single image in Open Data Hub UBI based. We want to finish the mixing of Open Data Hub and Kubeflow. And of course, we want to get our testing CI/CD process finalized or maybe improved upon. So that's it for the roadmap. So, and from an operator perspective, I always like to show this image because it shows all the potential of an operator. And I love operators. I think operators are the best thing that happened for the Kubernetes world. Open Data Hub is Go-based right now for the KFCTL operator, and it is phase 1. So it's basic install. But we're looking forward to all the different phases that we have down the line, and we hope to kind of little by little step to the different phases to make it better and improve upon the process of installing, getting data, updating, auto-updating, etc. So what is Kubeflow? So Kubeflow is one of the most popular AI/ML end-to-end platforms that run on Kubernetes. It provides a lot of tools also, but it's more focused toward the model, the model creation, the model training, the model serving, and then so you have tools such as TensorFlow and Pytorch for model training. For serving, you might have something like KFServing and Seldon, and for pipelines, there's the Kubeflow Pipelines that are based on Argo. And I just wanted to let you know that this team took quite a while to get Kubeflow optimally running over OpenShift, and all the changes that we have and added, we pushed up to the community. And then today, if you go to kubeflow.org, I think it's the website, yeah, kubeflow.org, you'll see that on the menu item, there is a Kubeflow, how to run Kubeflow in OpenShift, and that was part of the work that we did. So what is included in Open Data Hub 0.6.1 today? So this is a drill down on all the different components that if you install Open Data Hub today, you'll have most of these components. So let's start first with the data engineer or the business analyst, the top box for data analysis. You'll see we don't really actually have storage, but we have access to storage. So you can have S3 access to self-storage or SQL access to Postgres or any other SQL database. For streaming, we include Kafka Streamzy. For data exploration, and that's more of maybe the data engineer and business analyst, we have Superset and we have Hue. For metadata, we also include the Hive Metastore and the metadata that's part of Kubeflow. And for processing, we have Spark and Spark SQL Thrift. On the bottom right, orange box, we have the data scientist tools. The first thing is interactive notebooks, and I would just want to stop a little at this box. It shows basically the goal of Open Data Hub of integrating things together. We're not just providing these tools in one installation and that's it. We're trying to integrate things together, and this is one example where we have Jupyter Hub integrated into Red Hat OpenShift OAuth. So when you sign in into Jupyter Hub, you can use your OpenShift sign-in information. And we're also tapped into GPU. So when you launch your Jupyter Hub today, you will see a GPU process or resource that you can use if you have that set up in OpenShift. And you can say, I want to run my notebook on this GPU. So this is one of the things that we're trying to do, is get all the story together, linked together with all these tools. For distributed model training, you have TensorFlow, Pytorch, Spark, and for hyperparameter tuning, which I will show today in the demo, we have KTib or KATIB, if you like. And then for machine learning applications, we also have a really exciting tool called the Open Data Hub AI Library, which provides you with already trained models that you can serve and start to use right away. And for pipelines, you can either use Argo on its own, which comes with Open Data Hub, and we have the latest release of Argo, or you can use Kubeflow Pipelines. On the production side, for serving, we can do TensorFlow serving, Seldon, and then on the monitoring side, we have Grafana and Prometheus is also included. And that could bring metrics for any Prometheus exposed endpoint on these tools. A lot of good information you can get once you serve the model and it's actually in production. You can get a lot of information out of that and just graph it and model it with Grafana. For pipelines, again, the DevOps part of the world, they might also be using Kubeflow Pipelines. So that's what you get today with Open Data Hub 0.6. This is our last slide before our demo. So these are links, and I think Burr already posted these links on the YouTube channel. So our Open Data Hub site is opendatahub.io. For contribution to code, please visit our GitHub. Our group name is opendatahub.io. That has multiple projects and multiple repos under it, depending on the different components that go into the operator. And then we have community mailing lists, an announce list, and contributor list. And finally, we have our community meeting that's open to everybody that happens every other Monday. Please join us just to know, just to get an update on how it's happening in Open Data Hub. And if you're interested in contributing, you can always ask questions in that meeting. So Burr, if you don't have any more questions for me on the slides, I'm going to go ahead and do the demo.
I do have one question because it came up during your session as you were presenting, and I'm curious. You mentioned that there were challenges associated with getting Kubeflow working from vanilla Kubernetes and working on OpenShift. Can you give us just a couple insights as to what the challenges were and how you overcame them?
Yeah, absolutely. So a lot of, you see all of that all the time when moving from Kubernetes to OpenShift. Containers wanting to be root. Right? And then, we have to go into rebuild the container and make sure that it's not asking for root, or they're asking for a UID or an FS group that's not within the range of the allowed pods within the OpenShift namespace. We have to change that too. And then we also had, maybe I skipped this and I'll explain it a little bit more here, is that Open Data Hub in the Ansible world was namespace bound. So you install the operator within a namespace and you can install everything else within a namespace. Kubeflow on the other side came cluster-wide, and there was a lot of cluster-wide permissions needed. So we tried to cut off these cluster permissions because not every single component needs to be cluster-wide. And from OpenShift, we really take care of these things with security and making sure not every component has cluster-wide permissions. So these are a couple of things that we faced. And actually, we're still trying to kind of, fix them here and there. And you'll see one of the components that I'm going to demo now, which is called Kale. It requires root, which I gave it, but, we're not really, it's not part of our release. It's just something to show you forward looking what's happening in Kubeflow.
No, that's very, very insightful, and thank you for that, because that is a common question we get from folks all the time. Is I live in a Kubernetes world today, but I'd like to migrate to OpenShift. What are some of the things to think about? Those root level images, right? Namespace bindings, basically dealing with SCC, right? As well as RBAC and all the, essentially, right? OpenShift is highly secured by default, and many of these things were built in an unsecured way.
Yeah, absolutely. Those are all problems we can solve. It's just you have to pay attention to them. Yeah. Any other questions?
Alexi also points out that with an OC migration, I guess OpenShift migration, taking into account the PSP.
Is that a question or a statement?
A statement.
Good. Good. I don't have to answer.
All right, well, fantastic. Let's see the demonstration. I think people are always excited to see the live demonstrations of things, and I'm curious to know what it looks like.
Yeah, so hopefully the demo gods are with me today. I did send a prayer this morning. Well, the first thing I'm going to show you guys is, hopefully you can see my screen. If not, let me know, Burr. I'm going to show you, I know everybody here, I'm pretty sure, knows how to install operators, but I want to show you how to install Kubeflow from the Open Data Hub operator, because it's not by default. So if you go here, you'll see this is an OpenShift cluster. Just go under operator hub, and then look for Open Data Hub. So you'll see here under community, Open Data Hub operator. You can spend some time maybe reading this. You'll see here all the components. These are the components that actually come with Open Data Hub. There's more components that come with Kubeflow that we have not listed here. And you hit install. You'll see here the two channels that I talked about, the beta and the legacy. The legacy is the 0.5. Beta is what you can use to install Kubeflow. And I'm going to focus a little more on Kubeflow in this presentation. All right, and we hit subscribe. And we wait for it a little bit. Here.
And there,
go ahead.
There was a question last week that you corrected me on a little bit later, that this operator is only available within OpenShift Container Platform. It is not an operator available on Operator Hub.
That's correct. OperatorHub.io. So OperatorHub.io is Kubernetes-based operator. Open Data Hub at this point is only OpenShift-based operator. I don't think it'll take much to do Kubernetes, but we just haven't really given it attention and time. Yes. All right, so we see that it installed successfully, and then what you want to do here at this point, which I've done before, I think. So you'll see here the project where it's installed is the OpenShift operators, and that's where the cluster-wide operators get installed. So now we want to install Kubeflow, which is an instance of the API that's provided by this operator. So you create a new project, you call it Kubeflow, and at this time, please call it Kubeflow. And you'll see the installed operators is the Open Data Hub that we just installed. So to be able to install Kubeflow, what I'm going to do here, the default example that comes for the API, the instance here that you'll see in a second, is Open Data Hub, but we want Kubeflow in this little demo. So I'm going to go to the example, and this is in GitHub, and you'll see OpenDataHub.io is our project on GitHub, and this is the manifest to install Kubeflow. So I'm going to Rob and copy all this. And let me just spend a little time maybe here. So this is KFDev. This is the API that's provided by the operator. And all these different things here that you see, they are components. They are components that will be installed with your installation. You can mix and match. I mean, you can maybe customize this by deleting some of them if you don't want them, you're not using them. The first one, which is important, is Istio. If you have Istio already installed on your platform, you can skip that one. or keep it. We'll keep it here. And then all the other little components, the dashboard, the Jupyter Hub, and all the different components that you want, you can mix and match. And you'll see that some of them are actually commented out. For example, this KFServing is because we have not had time yet to adapt this to OpenShift. So if you do comment it out and try and install, most likely it will help. But we keep it there commented, basically, to remind everybody that we're working on it. So I'm gonna copy all this, and I'm gonna go back here and create an instance. This is the Open Data Hub. That's the default example, but today we want to do Kubeflow. Right? I'm going to hit create. And you'll see here now that all the pods will be installing here little by little.
Can you hit Command plus there, make that font a little bit bigger? Yeah. Or Control plus? Yeah. All right. Fantastic.
Yes. So we're not going to wait for this. I have another installation of this, and that's where we're going to do the rest of the demo. But you get the gist of how to install Kubeflow. I think you're all good to go. And we're going to hop in here in another place where we installed Kubeflow before, and you'll see all the components and all the pods running. So you'll see TF jobs, the workflow controller is the pipeline, you'll see Pytorch, you'll see the notebook, and all the other stuff here that we have. So in this demo, I'm going to do two things. I'm going to explain how to go from notebooks to pipelines in Kubeflow. And this is a new feature that the Kubeflow team has been working on, and I think it's pretty exciting, and it's UI driven, and I think the user experience is really good. And the second part, if we have time, I will run just a Kale job to show you how Kale works. So, okay, so we installed Kubeflow, now what, right? How do I get to the dashboard? Since we installed Kubeflow using Istio, we actually have to go to the Istio system, and then we have to go to the routes. And the ingress route that you see here, that's the pointer to your world of Kubeflow. And you click on this, and that will bring you to the main page of Kubeflow. Now, what you'll see different for you the first time is that it will ask you to log in. Please put something like a useful name. Don't ignore it or anything, because that useful name is going to be created here. It's a namespace for you. They're creating a main namespace for you. That will be your profile. And that will be the space where you will do two things. You will be able to create notebook servers and run Kale jobs. Pipeline is not part of the story today because they're not there for multi-tenancy. So the dashboard that you see here, shall I make that bigger too?
Yes, please. But this is the dashboard that you'll hand to your data scientist at this point? Or who would use this dashboard?
The data scientist, exactly.
Okay.
So most of the functionalities here is data science functionality. Maybe data engineers if they want to create pipelines. Yeah. But mostly data scientists. So you'll see here the dashboard. I've been working on this for the demo for a while. So you'll see a lot of stuff. The recent pipelines, the recent notebooks, and all the recent pipeline lines. So I'll explain that in a little bit. So if you'll see here on the left side, you have a menu for pipelines, notebook, Kale, and artifact store. So we'll start first with the notebook server. And make sure you select your namespace. All right, so this is my namespace, and this is one of the notebook servers that I worked on before, but I'll launch a new one just so you guys can see. Let's give it a name. I'm going to call it DevNation. All right, and then for this demo, if you want to include Kale, which is the tool that I'm going to explain here in a little bit, you have to use a custom image. And the custom image I'm going to get from the Kale team within their workshop here. And I'm going to specify this. And then here you can also add a volume because you need the volume to kind of move. I'll show you here an example too. So leave it this default as it is and hit launch. All right, so you'll see here what's happening is if we flip-flop back to the namespace that I create, that's my profile, and you look at the workload, you'll see a DevNation pod. This is actually your Jupyter environment that's being created. But we're not going to wait for that either. We're going to hop straight to this one, and this is what you'll see. Basically, this is Jupyter Lab, And I'm sure a lot of people here are familiar with Jupyter Lab. And what I did is I uploaded this notebook for house prediction. And we're going to go through this. The idea here is, the data scientist is going to create this notebook. They're going to go through, analyzing or trying to analyze the data, bring the data, have access to the data, and then create their models. And after they're done, they're going to say, okay, well, how do I turn this into a pipeline? Because I want this to run maybe daily, or I want this to run every time there's new data, or have some other triggers. So let's go through this a little quick. So I got this from this really cool tutorial online, and I have a link for it. It predicts basically it predicts whether the house price you give it is above or below the median house price. And the data that we bring here has information, the size of the house, how many chimneys it has, etc., stuff like that. But the prediction is whether it's above or below the median house size. So we do let's run it here. It's really quick. I actually on purpose made it small so that we don't get lost in the data science world. So this is the imports, and then here is where we bring the data in. We divide the data sets into features and labels. The feature is what you train the model. The label is what it actually predicts. And we break them down into training and validation sets. So not very important, but anyway. So and then after that, we take this data, we build the neural network. There's 3 layers of this neural network. I'm not going to go into details on this either, but basically the metrics is for accuracy, which it will print it out at the end. So let's just run this for fun. And then it goes through all these epochs, testing, and in the end it will print out a number and tell us how accurate this model is, 0.9. I think that's good. If not, yeah. So there's no way is this a perfect way of doing model training. That's just an example here. So good. Now I want this to turn into a pipeline, right? So I wrote all this and I want this pipeline to run a certain interval or whatever. So this is the Kale, which is a new feature that the Kubeflow team is working on. I'm going to enable it. And what you'll see here is that it tags every box, and that's because I specified before what I want this box to be as part of the pipeline. So if you hit this little, and let me know if it's not clear, Burr here. If you hit this little edit button, you can pick the cell type that you want, whether it is a pipeline step or an import or a function, or you can even skip it. So for this, it's import. What import means is that it's going to be on every step of the pipeline. And then my first pipeline step is prep data. You'll see here, prep data, it's a pipeline step. And then my second one that is building and training the neural network depends on prep dev. So I'm going to say depends on prep dev, and I'm also going to pick a pipeline step. So at this point, I've told Kale, this tool, these are the steps I want in the pipeline. So compile and upload my pipeline. I can name it, just the default experiment, gave it a name, house prediction data. And then I'm going to compile and upload. There's other options here, but I'm going to pick compile and upload, and I'll tell you here in a little bit why. So pipeline was saved. Awesome. So I go back to my pipeline UI, and I'll see this new pipeline here. And that's basically the pipeline that it just created. And you'll see there's a step here. That step is creating a volume so that it can exchange different data between the steps, right? When you prepare the data, you put in a data frame, and that has to be passed to the model. Now, this, as it is, let's look at the source. It's pretty interesting. Maybe it's too much code here, or maybe it's hard to see, but basically it defines the DAG is basically how you draw your pipeline and the different tasks. And then you have the templates of the pipelines at the bottom. But if you'll see here, this is the container of the prep step, and you'll see this is all the different code that I had in that one cell in the notebook. And same for the next one, which is actually creating the model, also the code. That's pretty cool, right? Unfortunately, today, we cannot run this as it is. We have to make some changes. So changes to adapt it to OpenShift. And one of the changes is actually how our Argo runs in OpenShift. This assumes that you're using Docker. They use the Docker API to move things from one place to another. On OpenShift, we don't have Docker, we have Creo. So we have to use this special Argo executor, and we have to use special volumes So, but anyway, I changed it and I adapted it, and you'll see it has root. Big no-no, but that's just for this demo. I had to give the workflow root because the image that I used from the Kubeflow Kale team required the root. So we can run this, create a run, and we'll say test. Really innovative, but we'll just try here. You'll see I ran it many times to make sure that it works. So at every step of the pipeline, you'll see the output of the pipeline, what happened. And, let's hop here really quick. This pipeline is actually not happening in my namespace. As I explained before, it's happening in the Kubeflow namespace. And you'll see one completed here. This is the first step. And then the second step is going to be running here pretty soon. See the first one, it got the data, and you can read the logs, what it did, all the different data frames for training and evaluation, and it's training the model right now, and you'll see all the training running, and then at the end it will skip the accuracy. So that's in a nutshell how to go from notebooks to pipelines using this really new tool that Kubeflow is working on. And I'll stop here for a little bit, Burr, if you have any other questions before I move to the second part of the demo.
We should probably continue because we're out of time, so we'll just move to the next phase.
All right. All right, so for the next phase, I will do it really quick. This is just an example of hyperparameter tuning. So hyperparameter tuning exposed this resource called experiment, and I will show it to you really quick. It runs in your namespace, and what you do is you tell the experiment, it's type experiment, you tell it to run how many trials you want to kind of experiment with your model and what metrics you want to experiment with and what's the actual objective. Here we want to maximize accuracy, and we are trying to basically play with two parameters, the learning rate and the batch size. And this is a neural network for MNIST predictions, basically seeing a handwriting and trying to predict what's the handwriting or what's the number or letter. And then you run this, and this is distributed training, so it will run in parallel. And let me just show you. Oh, yeah, because I ran it multiple times. So if we are out of time, Burr, let me know, and I can just show you the result of the previous experiment that I did. Or I could just run this again.
Run it again. Interesting, though, that there's an experiment CRD, right? Custom resource definition that you're leveraging here. So I like that a lot. There is one question, though, that came up with Alexi, and I had the same question in my own head, which is, what are you guys doing with Istio here? Why are you leveraging Istio?
Well, Istio is basically a better way of doing routing data into the project that you have. You can define different endpoints and define how you want this data to go in. And if you have special rules on this pipeline of data going in, you can specify these special rules on it. Okay, and actually I wanted to show you so these are the different jobs that are running, the workers. And if I do, I'm going to show you one little thing before the end of this demo, how the UI shows you the experiment results. And you'll see here, so it did 3 trials, and I think the 3 are still running. And I won't go deeper, but it's basically running this container, and this is the code. Let me just show it really quick here. So this is the code that's running inside the containers, and you'll see here the code exposes API to actually add these parameters and change them within the model and then report back the results. But I want to hop really quick here to the UI part of it, which is interesting. So you go to data menu, and then you go to hyperparameter tuning, and you pick here your hyperparameter tuning monitor, and that will show you the experiment that just ran, and will show you a graph. So it will show you all the 3 things that succeeded, the ones that are running. And this graph shows you, for example, for accuracy, that's around 0.995. Your learning parameter was 0.018 and your batch size 1189. So you can look at this graph and figure out, okay, what are the best parameters for this accuracy number that I'm trying to get out of. Well, this is a really simple example that I just got from the actually Kubeflow community, but I'm sure there's other more complicated things that you can do with this. So that's the end of the demo. So any questions?
But that is absolutely fantastic. And we are out of time, so we won't have time for more questions. But I do appreciate what you showed us here, and that is the ability to ensure that our models are not drifting over time, right? You know, essentially, we're constantly running experiments, see if the model is still as performant. And when we say performant here, we don't mean the runtime performance, we mean the prediction performance, right? And that's really cool. I didn't realize that was all in there, and I didn't realize it was all in part of Open Data Hub. That is a very cool
Yeah,
thing.
absolutely. Yes.
Okay. Well, thank you so much.
Please join our community. Yep.
Yes. I added the links to the chat for the mailing list, the website. You guys come to the community meetings. I was unaware of the community meetings that happen on Monday as well. But we would love all of you here to actually come check out Open Data Hub and give us more feedback on it. Run this thing in your OpenShift cluster and tell us if it works, doesn't work, or what else you'd like to see. Because that level of feedback is what creates that virtuous cycle, that feedback loop, that flywheel that helps us make this better for all of you guys as well. And it's all open source. It should be mentioned it's all open source and all available to you. So we need your feedback. We need your contributions there. Yeah, and so actually Alexi does have a question about GPUs, and it can be leveraged if it's in the cluster. And guess what? Our next session coming up in a moment with Pete is going to be all about GPUs. So if you're interested in GPU technology and how you might leverage it, that is our next session. So come right back in a few minutes, Alexi. We'll be starting up with Pete as soon as we get done here. Thank you, Juana. Awesome stuff. I really enjoyed the presentation. You all out there. Yeah, everyone out there, have a great day, great evening, wherever you might be. Pete just sent me a text message that said, hey, it's raining really hard at his end. It's raining hard for me also, so hopefully you're having good weather where you're at. Okay? Well, we got to get out of here. I thank you all for your time, and we'll see you in the next session in just a few more minutes.
Thank you, Bert. Bye.
Bye-bye now. Thank you.